Yes, sir, please. Yes, so many are absent. Right, sir? Meanwhile, you solve these things. The third order kinetics, solve those things. Hmm. Solve. Solve all these things. Done. You keep not solving money. What we wrote earlier. If it is elementary, can I write 3a gives rise to products? Then what do you write? R equal to k into 80 cube. Respond. Then n equal to 3. Then obviously it becomes third order kinetics. Please. Then here can I write R versus A2 cube graph? A2 cube graph will be a straight line. Now, if I substitute n equal to 3 in this equation, what you will get? 3 minus 1, 2. M value is 1 I am taking. So 2t. A minus x power 3 minus 1 means a minus x square minus 1 upon a square. So what you will get? K equal to 1 by 2t. K equal to 1 upon 2t. 8t square minus a naught square. If I plot a graph between 1 by 8t square, then it becomes 2kt plus 1 upon a naught square. Correct? So here if I plot graph between 1 upon 8t square versus a t graph, then intercept 1 upon a naught square, slope becomes equal to 2k. Correct, sir? Correct or not? Simply substitution, nothing there. Correct? Now if t equal to t half, what do you write? When t equal to t half, instead of x, I will write a by 2. Substitute x equal to a by 2 here. T half equation. T equal to t half. 2 power 3 minus 1. So 2 square means 4. 4 minus 1. 3. 3 upon a naught power 2. Here again 2. So 2k a naught square. Numerator 3. So what do you get? T half equal to 3 upon 2k a naught square. Right? So T half equal to 3 upon 2 a square k. Yes, sir. So here also I will write 3 upon 2 a naught square k. Respond. Correct or not? If I plot a graph between t half versus 1 upon a naught square, how the graph is? Slope equal to 3 upon 2k. Sir, no one is doing, sir. Huh? Simply, I am substituting n equal to 3 in this equation, nothing there. Third order kinetics. That's all. Accordingly, I am calculating half T half and K equations. Right? Respect to examples, sir. I think let me copy that examples as it is. Do you have your target booklets with you? Once open, there they have given examples. Let me open same target book. Now see here, for zeroth order reaction, they gave some examples. One example, decomposition of hydrogen iodide or ammonia on metal surfaces. This is one example for zeroth order kinetics. H2 gas plus Cl2 gas, another reaction. H2 gas plus Cl2 gas in presence of sunlight to form 2 HCl gas. Follow zeroth order kinetics. Here I will write dx upon dt is equal to k into zeroth order means Rate of reaction is independent of concentration of H2 as well as Cl2. That's why it is called zeroth order reaction. Rate remain constant. Now, examples for first order reaction. One example, thermal decomposition of nitrous oxide, right? So I can write that in this way: N2O gas gives rise to N2 gas plus O2 gas. So balance this reaction accordingly. I will write 2 here, 2 here. Reaction got balanced. Same way, one more reaction. Decomposition of NO2 gas. This is also example for second order reactions, right? So I am writing decomposition of NO2. So I am writing NO2 gas on heating gives rise to NO gas plus O2 gas. So balance it. So I am writing it as 2 moles of this, so 2 moles, 2 moles, 1 mole. Reaction got balanced or not? 4, 4. Similarly, decomposition of hydrogen iodide. If it is done on metal surfaces, zeroth order kinetics. Otherwise, it is second order kinetics. So decomposition of hydrogen iodide. 2Hi, yes sir. H2 plus I2. Example of second order kinetics. Similarly, while we are studying reaction mechanism, we have seen bimolecular nucleophilic substitution reactions, SN2 reactions, follow second order kinetics. Similarly, elimination reactions, E2 eliminations, E2 elimination reactions follow second order kinetics. Right? Next, hydrolysis of ester in basic medium. Hydrolysis of ester in basic medium. Then also it follows second order kinetics. If it is in acidic medium, follows first order kinetics. If it is basic medium, second order kinetics. So these are all examples of second order reactions. We also call this as saponification. Balance, man. Oxens 4 over oxens 4 balanced already. Why not N2 plus 2? Are you breaking NO or N2O? Nitric oxide, bond order 3. How to break it? NO is strong, na? Bond order 3, na? NO bond order. How to break it? Next. Again, we are taking example for third order reactions. NO plus Cl2 gives rise to 2NOCl. Another example, FeCl3 with SnCl4. Plus 3 converted to plus 2 means SnCl2 gives rise to FeCl2 plus SnCl4. Take 2 moles, 2 moles. So all these follow third order kinetics. So examples of zeroth order, second order, third order, right? Now coming to first order kinetics. Before going to first order kinetics, sir, see this. Before going to first order kinetics, what we have done in integration method? How you calculate rate constant K in integration method? We brought one equation by using law of mass action for dx upon dt, followed by integration, applying the limits. Then we are finding T half. Correct? If it is nth order reaction, what is the equation K? For nth order, what is K equal to? What is K equation? 1 upon M T n minus 1 n minus 1 1 upon a minus x power n minus 1 minus 1 upon a power n minus 1, where n is not equal to 1. If n equal to 1, what is the equation? 1 upon mt, right? A upon a minus x. Now, in this case, what it is? T half equation. 2 power n minus 1 upon k a power n minus 1. Respond, sir. Into n minus 1. Respond. If m equal to 1. If m is not equal to 1, we will write that m back. If it is first order, what you will write? T half equal to ln 2 upon, right, mk. Correct? This is when n equal to 1, when n not equal to 1. Here n may be either 0, 2, 3 and so on. Here n is 1. Only if you remember these two equations, automatically you can derive remaining. Correct? Say something. Now I am giving one task, try to complete. I am taking one reaction in this way. A reactant A combined with reactant B to form products. Let the rate constant be K. It follow second order kinetics. At time t equal to 0, let the concentration of A be small a, B is small b. When time t equal to t, let it be a minus x, b minus x. Then what is the K equation? Find rate constant K equation. Find rate constant K equation. Online. Is it possible? Online student, someone respond, sir.
Yes, sir.
What? Yes, sir. No one is responding properly. Huh? Solve this one. What you will write? What is rate equation? What you will write, man? Instantaneous rate equal to what you will write? Minus dA by dt, which is equal to minus dB by dt. According to law of mass action, what you will write? Rate equal to K into A minus x power 1 into B minus x power 1. Respond. Now this and this both are rates only. Either I can write that in terms of dA by dt or maybe dB by dt, anything. So I am writing, therefore, minus dA by dt equal to K into A minus x into B minus x, right? So what will write here? dA. What is change in concentration of A? Final minus initial. Final is A minus x. Initial is A. So A minus x minus A. Minus x. Already minus is there. So what you can write? Dx upon dt is equal to K into A minus x power 1 into B minus x power 1. Correct, sir? Right? If you don't come to classes, how you will understand? Why we have written it as dx by dt? Instantaneous rate. Right? Sir. Right? What we have to write? Change in concentration of reactant. What is concentration of reactant? Final minus initial I will write. Final is A minus x. Initial is minus A. What is this value? What is that value? Minus x. Negative is also there. So what you will write? It is nothing but equal to dx by dt, na? Response, sir. 1 minute. One more thing. I have to write rate as Total change in concentration of A by total change in time. What is total change in time? T. What is total change in concentration of A? A minus X minus A. And its concentration is decreasing. That's why I will write negative. So what you will write? Minus X by minus A plus A plus X by T. If a change in time is negligible, then change in concentration of X also. That's why we are writing it as. How many times we discuss? At least this is 20th time. Minimum. Right. Now integrating on both sides, sir. Integrate on both sides. What do you write? Integrating on both sides. Integral dx upon a minus x into b minus x is equal to integral k dt. Between the limits 0 to x, here between the limits 0 to t. Correct, sir? Now, what is this value? Can I write that as 1 upon a minus x minus 1 upon b minus x? What is this? 1 upon a minus x minus 1 upon b minus x. Take LCM. What do we get? A minus x minus of b minus x upon a minus x into b minus x. Correct? Now it becomes a minus b upon a minus x into b minus x. Correct? What, man? Ah, okay, man. Okay, man. So it becomes b minus x minus a plus x. Respond? Correct? So it becomes b minus a. Bring that b minus a to this side. So 1 upon b minus a into 1 upon a minus x of minus 1 upon b minus x is nothing but equal to 1 upon a minus x into b minus x. Correct? So instead of this term, can I write this term? Can I write it? So what will be this equation now? Integral 0 to x 1 upon b minus a 1 upon a minus x minus 1 upon b minus x is equal to integral 0 to t k dt. Acceptable? Can I write that or not? Sponsor. Now integrate it. What is integral of 1 upon a minus x or integral of a minus x power minus 1? What will you get? That implies 1 upon b minus a into what is this term? Integral of this term. A minus x minus 1 integration. Again, I need to write minus 1 denominator. Integral a minus x power minus 1, man. If it is not 1, then I will write integral x power minus n dx. What is it? X power minus n plus 1 upon minus n plus 1. Correct? If it is integral x power minus 1, then what you write? Log x. Right? Response, sir. Correct or not? So if n is not equal to 1, then this is correct. If n equal to 1, we have to use logarithm. Now what is this value? What is it? ln a minus x differentiation of this term minus 1 over minus log b minus x differentiation of this term minus 1. So it becomes a plus between the limits 0 to x is equal to k t between the limits 0 to t. Correct? Now upper limit minus lower limit. If I substitute upper limit, it becomes a minus x. When I substitute lower limit, it becomes a. Same way here, b minus x minus b. So what you write? minus ln a minus x plus ln b minus x. Upper limit substituted. Minus, when I am substituting lower limit, it becomes minus ln a plus ln b. Then what is the net equation? This becomes minus ln a minus x plus ln b minus x plus log a minus log b. From these two are what I have to do. Whichever are negative goes to denominator, right? So can I write this as log a into b minus x upon b into a minus x? Correct? So I'm writing directly here. That implies 1 upon b minus a log a into b minus x upon b into a minus x is equal to k. Over. Therefore, k equal to. Therefore, k equal to 1 upon t b minus a log a b minus x upon b a minus x. Over. In this format, can we derive rate constant equation for whatever the reaction they might have given? Can you do it? There we can solve it for a plus 2b gives rise to products. 2a plus b gives rise to products. A plus b plus c gives rise to products. If it is a plus b plus c, what you will write? dx by dt equal to a into a minus x into b minus x into c minus x. Accordingly, we will do again. Method is same, right? If it is a plus 2b gives rise to products, what I will write? Dx by dt equal to k into a minus x plus, into b minus x square. Now, accordingly, I will solve. Understood, right? Now, sir. So we are done with other order reactions. Other order reactions means we are done in case of zeroth order, second order, third order. Now, whatever example we have seen, that is also second order. Now we are going to see about first order kinetics. So we will see first order kinetics. See this? If I write a reaction in this way, MA gives rise to products. Rate constant K follows first order kinetics. Right? Then what is rate constant K equation? What is rate constant K equation? Or can I write this as 1 upon M minus dA by dt is equal to K into A minus X power 1. Response, sir? Correct or not? So what you will write it as? Dx by dt equal to M K A minus X power 1. What is dx by dt? Rate. So what we can write rate now? Rate of reaction. Rate of reaction is equal to M K A minus X power 1. Because it is following first order kinetics. Any questions in it? We are plotting 3 types of graphs. Say something, sir. For every order, we are drawing 3 types of graphs or not? Rate versus concentration graph, right? After that, concentration of A after T time T versus T graph, then T half versus A naught graph. These are the 3 types of graphs we are drawing. So again, here also I'm doing the same. I am trying to draw 3 types of graphs for first order kinetics. So I will do one thing. I am copying this. Same 3 types of graphs I am drawing here. Same 3 types of graphs I am drawing, sir. So observe first graph. What is that first graph? Rate versus concentration graph. Correct? So instead of a minus x, can I write at power 1? Can I write it? So what is r equal to? R equal to m into k into at power 1. So what is rate versus at graph equation? What is the r versus at graph? How the graph is? R versus at graph, how it looks like? Rate versus at graph. Intercept 0, slope mk. So intercept is 0, slope mk means, can I say it is a straight line passing through origin? Done. Now, second case. Second case, sir. I need to plot a graph between AT versus a time graph. How the graph will be? AT versus time graph. Respond. Rate means nothing but dx by dt is equal to m into k into AT is nothing but equal to a minus x power 1. Bring that to this side. So dx upon a minus x equal to mk dt. Integrating on both sides between 0 to t, 0 to x. What is integral 1 upon a minus x dx? Log a minus x negative between the limits 0 to x is equal to mk t between the limits 0 to t. So upper limit x minus lower limit 0. So what you will get? Minus ln a minus x minus of minus plus ln a is equal to mkt. So what is k equal to? 1 upon mt log a upon a minus x. Correct? So I am writing the same. K equal to 1 upon mt log a upon a minus x. Instead of a, can I write a naught? Instead of a, can I write a naught? Instead of a minus x, can I write at? So the same equation can written as k equal to 1 upon mt log a naught upon at. Any questions are in this? Is it acceptable or not? Online. Done. So all this stuff is nonsense because of how many times we have solved the same method. Right? Now bring this mt to this side and log term to this side. So what you will get? mkt. If I bring this log term to this side, e power is equal to a naught upon at. Correct? So what is at upon a naught equal to now? E power minus mkt. Bring that a naught to this side. So what you can write as? At equal to a naught into e power minus mkt. Correct, sir? Now, if I plot a graph between at versus t, now tell me how the graph is. I'm plotting a graph between at versus t. This is at, and you will find t term here. If I plot a graph between at versus t, how the graph is? Hey, say something. How the graph will be? Huh? What, sir? How the graph look like? Rectangular hyperbola decreases exponentially. Hurry, yeah. This is AT equal to. This can be written as A naught upon. This comes to denominator e power mkt, correct? If t is increasing, what happens to this? Increases. If this increases, e power term means denominator is increasing exponentially. If denominator increases exponentially, what happens to total term? Decreases exponentially. How is decreasing exponential decrease graph? Correct, sir? With that graph only we started this chapter, man. Right? A is nothing but concentration of reactant. What happens to concentration of reactant with time? Decreases exponentially. Correct? If it is zeroth order, decreases linearly. Correct? Now, instead, if I want to plot another graph, observe, sir, I am trying to plot another graph. For our convenience, I am trying to plot one more graph. Now, see this. Instead of writing AT versus T graph, I am writing this MT to this side. So, MKT equal to log A naught minus log AT. Can I write it? Bring this to term this side. Log AT term equal to minus MKT plus log A naught. Correct, sir? So if I plot a graph between log AT term versus T, how the graph is? Slope negative, intercept positive. Correct? So what is this intercept value? A naught and slope value minus MK. Correct? Can we draw it or not? So another form of equation I am writing here. What is it? Log AT equal to minus MKT plus log A naught. In this way, we can plot different types of graphs, man, based upon our assumption. The same equation we are rearranging and we are plotting different graphs. Right? Now, at a time t equal to t half, what happened? X becomes equal to a by 2, half-life. If x becomes a by 2, what happens to this equation? Substitute x equal to a by 2 here. A minus a by 2. A by 2. 2 goes to numerator. A cancels. So what you got? Log 2. Right? So 1 upon mt log 2. Instead of t, I have to write t half. Bring the t half to this side, k to this side. So what you got? T half equal to upon mk. Is there any concentration term in it? No. That's why T half in case of first order reaction is independent of initial concentration. A term is not there. Right? So it should be constant. So straight line. Correct, sir? Wait, auto. Right. Zero. Oh, sorry, first order. Any questions in it? No. Units of rate constant K. Here, let me write examples also. Some examples for first order reaction. Right? So, and we will see units of rate constant K. What are the units, sir? What are the units of rate constant? Or if it is nth order reaction, we are writing R equal to K into concentration of A power N. correct? AT power n. Then what is rate constant K equal to R upon AT power n, correct? What are the units of R? Mole per liter. What is concentration? Right, sorry. That is moles per liter per time. Rate units, man. Moles per liter per time. Denominator, mole per liter. Power n. So this goes to numerator. It becomes mole per liter power 1 minus n per time. Right? So units. Mole per liter power raised to 1 minus n per time. If it is zeroth order, what is the units? In case of zeroth order reactions, what are the units? Mole, later inverse, time inverse. If it is first order, time inverse. Second order, mole inverse, later, time inverse. Third order, mole square, later inverse square, time inverse. Response are, and so on. Right? Response are. So in which, by observing the rate constant units, in a question they have given rate constant units. By seeing that rate constant units, can you say it is first order or second order and so on? Done? Any questions in this further? Right? So we need to see some examples for first order kinetics. Right? Examples are first one. Decomposition of hydrogen peroxide. The decomposition of hydrogen peroxide. So what we can write? H2O2 gives rise to form H2O plus half O. Correct or balanced or not? Or I will write 2H2O2 gives rise to 2H2O plus O. So decomposition of H2O2 follows first order kinetics. Same way, pseudo first order reactions. Examples of pseudo first order reactions. Acid hydrolysis of esters. Pseudo first order reactions, they are also following first order kinetics, right? So hydrolysis of ester in acidic medium, I will write as acid hydrolysis of esters. Then one more example we have seen, inversion of cane sugar. It also follows first order kinetics or not? Inversion of cane sugar. All these are examples of pseudo first order reactions. Decomposition of ammonium nitrite. What is the product, sir? N2 plus 2H2O. As we are heating, I will get gaseous forms. Next, very, very important point. All radioactive disintegrations follow. All radioactive disintegration reactions follow first order kinetics. Right? Same way. Decomposition of N2O followed second order kinetics. Decomposition of NO2 followed second order kinetics. Decomposition of N2O5 follows first order kinetics. Right? Decomposition of N2O5 in presence of carbon tetrachloride solution follow first order kinetics. So these are all examples of first order reactions. Right? Next, sir. I think in our target booklet they gave experimental methods of determining first order. One sec. Go to page number 6. Go to page number 6, sir. Integration rate equations. Under the zeroth order reactions already over. Now we are seeing first order reactions. Right? In that page number 7, they gave rate of radioactive decay that we need to discuss. Right? Under nuclear chemistry, separately we will discuss. Characteristics of first order. In that, they gave some examples. Right, sir? Decomposition of hydrogen peroxide, acid hydrolysis of ester, inversion of cane sugar, decomposition of ammonium nitrate, radioactive disintegration of radium, decomposition of N2O5 in CCl4. There one more reaction they gave. Decomposition of sulfonyl chloride. Decomposition of, if I write SOCl2, it is called thionyl chloride, right? So example, SO2Cl2 on heating gives rise to SO2 gas plus Cl2 gas. All these follow first order calculus. Done. Now, before going further, observe this statement, sir. All radioactive disintegrations follow first order kinetics. All radioactive disintegrations follow first order kinetics. So first we will discuss about that radioactive disintegrations which are following first order kinetics, and I will come back. Right? Now says, if any unstable nucleus, if any nucleus which is unstable, right? Any nucleus will be unstable because of many reasons. It may be unstable, right? More number of protons, more number of neutrons, more repulsive interactions, right? Because of some reason, it is unstable. Then it tries to attain stability by losing some particles. That phenomena of getting stability by emitting some particles is called radioactivity. We call that as radioactive disintegration, right? So unstable nucleus converts to stable nucleus by emitting certain particles. Those particles may be either alpha, beta, gamma, neutrino, neutron, antineutrino, etc. Right? Maybe positron also. Right? And so on. Right? And so on. So by emitting something, it converts into stable nucleus. We call this method as, this process as radioactivity. Right? Radioactive disintegration. Right? So the nucleus which is unstable, we call it as mother nucleus. Right? Mother nucleus or parent nucleus converts into daughter nucleus. If a daughter nucleus is not stable, again it will behave as parent nucleus and it will disintegrate to daughter nucleus and it proceeds. It goes on. Is it clear? Till you reach state. Right? So we call this as a parent. We call this as parent nucleus. And we call this as daughter nucleus. If a daughter is unstable, now daughter behaves as parent and again shows a disintegration to give another daughter and it goes on. Clear? Response, sir. Now, if I consider a nucleus A converts into B, if a B is unstable, then B converts into C. If C is unstable, it converts into D and so on. This type of disintegration we call it as sequential decay, or we call it as consecutive decay. We call this as sequential or consecutive. Right? Any questions in that? These decays, whether it is sequential or whatever it may be, these decays are classified into two types: natural, artificial. Right? Which are observed in nature, which are not observed in nature. These natural decays are again classified into four types: Fourier series, Fourier plus 1 series, Fourier plus 2 series, Fourier plus 3 series. Right? I'm repeating again. These decays are classified into two types. This is classified into two types: artificial natural. This natural again classified into four types. Right? What are they? This natural again classified into four types. What are they? Fourier, Fourier plus 1, Fourier plus 2, Fourier plus 3. In which I am underlining this Fourier plus 1. Right? These decays are again named after certain names: so thorium decay, actinium decay, and so on, uranium decay, and so on. The name of that decay process is based upon the nuclei which is having highest half-life. For example, if you take Fourier decay, in that Fourier disintegration, one nucleus will convert into another, that will convert into another, and so on. Among all of them, which nuclei is having highest half-life? Name of that series will be, or it is named after that particular nucleus. If thorium is the more stable, or thorium is the nuclei having highest T half, then I call this Fourier decay as thorium series. Are you able to understand? Online. Is it clear? We are,
Yes,
we
sir.
are discussing about types of radioactive disintegrations, in which we are classifying them into two types: artificial and natural. In natural, what are they? 4n, 4n plus 1, 4n plus 2, 4n plus 3. Right? So coming to 4n series, sir. We are talking about 4n series. Here, whatever the nuclei obtained, either parent or daughter or parent or daughter, whatever it is obtained, if their mass number is divided by 4, remainder must be 0. Then only it comes under 4n series. If remainder is 1, if remainder is 2, if remainder is 3, 4n plus 3, and so on. Right? This 4n series is also called as thorium series. Why it is called thorium series? Why it is called thorium series, sir? In the disintegration series, among all daughters generated, this is the thing with highest T half. That's why it is named after thorium. Now, for example, if you take thorium series, I am taking thorium 90 to 32 nucleus. Divide the mass number with 4. What is the remainder? Divide the mass number with 4. What is the remainder? 0. So it belongs to 4n series. Clear? Now, during this disintegration, I got final stable product, that is lead 82 208. Divide the mass number of 208 with 4. Right? Now, to convert this to this, some particle should emit. Right? So those particles may be alpha particle or beta particle or gamma radiation, whatever it may be. Some particle should exist. Some particle should be emitted out. We call that as radioactivity. Right? When an alpha particle emits, during alpha emission, What is alpha? Helium nucleus, no? Alpha particle means helium nucleus. If alpha is emitted, how many protons are gone or how many neutrons are gone? How many protons, how many neutrons gone? From one nucleus, one alpha gone. Means how many protons gone? 2. Neutrons, 2. So atomic number decreases by 2, mass number decreases by 4. So during alpha emission, Z means atomic number decreases by 2. A decreases by 4. In the same way, if there is any beta emission during beta emission, what happens, sir, in case of beta emission? Beta means E minus 1, 0. If this particle got emitted, what happened? The minus 1 got emitted. Means one neutron converted to proton. Right? Neutron converts to proton plus beta particle. Right? Now what happened to atomic number? Increased by 1. Mass number, no change. Right? Observe this, man. Sum of 1 and minus 1, 0. 1 plus 0, 1. Are mass number, atomic numbers. Right? So during beta emission, what happens to atomic number? Increases by 1. Mass number, no change. So during beta emission, Z increases by 1 unit and A remain same. Clear? Now see here. If thorium got converted to lead, now tell me here how many alpha particles emitted and how many beta particles emitted? How many alpha particles emitted and how many beta particles emitted? If alpha particle emitted, what happens to mass number? Decreases by mass number decreases by 4. So 232 minus 208 by 4. That's sir. 232 minus 208 by 4. How much? Minus 6 alpha particles emitted. So better I will write in this way, sir. Number of alpha particles emitted is equal to A2 minus A1 by 4. Where A2, A1 are mass numbers. Correct, sir? Now, what about number of beta particles emitted? How many beta particles emitted here? If I assume this as nucleus X man, atomic number Z1, mass number A1, converted to some Y, atomic number Z2, mass number A2. How many alpha particles are emitted? A2 minus, sorry, A1 minus A2 upon 4. I have to write A1 minus A2 upon 4, na? Decreases, na, mass number. So A1 minus A2 upon 4. Now, if this decreases, what about Z value, atomic number? Should decrease by 2. Correct? So, what should be Z? Can I write Z2 equal to 2 times of number of alpha particles emitted plus number of beta particles emitted plus Z1. Acceptable or not? Sorry, Z1. 1 minute. Not plus. Z1 minus 2 times of number of alpha particles emitted plus number of beta particles emitted. Correct or not? If one alpha particle emitted, atomic number decreases by 2. So Z1 minus 2. If one beta particle emitted, increases by 1 unit. Correct? Any questions in it? Clear? So I am writing this as Z2 minus Z1 plus 2 times of, instead of number of alpha, I am writing A1 minus A2 by 4 is equal to number of beta. Acceptable? Response, sir. Say something. So, number of beta particles emitted, what will be the formula? Z2 minus Z1 plus A1 minus A2 by 2. Now calculate how many beta particles emitted here. How many alpha? 232 minus 208 by 4. 32 minus 8. 20. 24 or 24 by 4. So 6 alpha. Right? So number of alpha particles are 6. Now what you have to write? 82 is equal to Z2 equal to Z1 minus 2 times of number of alpha 6 plus number of beta. Correct? Response, sir. So 90 minus 12. 90 minus 12. 70. Bring that 78 to this side. 82 minus 78. So number of beta particles emitted is 4. Correct or not? Check again. This is 90. How many alpha particles gone? 6 alpha particles gone. So atomic number should decrease by 12. 90 minus 12. Instead of 78, I got 82. Means there is increase of 4. 4 increase means 4 beta emitted. Response, sir. Correct or not? Any questions in this? Now I am taking second type of decay series. 4n plus 1 series. It is also called as actinium series. Sorry, Neptunium series. Neptunium series. So starting material, plutonium 94 241 converted to bismuth 83 209. Now tell me, sir, how many alpha emitted, how many beta emitted? 241 minus 209. 41 minus 9, man. 8 alpha, how many beta? 8 alpha means 16 should decrease. 94 minus 16. 94 minus 16. 94 minus 16 man. Became 83. So 5. So 8 alpha, 5 beta. Correct, sir? Any questions in it? Next series, sir. 4n plus 2 series. 4n plus 2 series. Also called as uranium series. Uranium 92 238 converted to lead 82 206. Now tell me how many alpha emitted, how many beta emitted? 238 206. How many alpha gone, how many beta gone? 38 minus 6. 32 by 4. 8. So 8 alpha gone. How many beta? 6 beta. Next, sir, 4n plus 3 series. 4n plus 3 series called as actinium series. Uranium 92 to 35 converted to lead 82 to 07. Now tell me, sir, how many alpha gone, how many beta gone? 7 alpha, 4 beta. Are you able to understand? So all these are natural decay processes in which this is no longer natural now. Because among all these decay series, this have lowest half-life. If it is having lowest half-life, it already gone to completion. If it is already gone to completion, now there is no 4n+1 series. So this series is artificial decay now. Earlier it is natural. During the time of formation of planet or asteroids, it is natural. Now it is. Reason, it is having low T half among all of them. Clear? Now see this. Naturally, how many types of isotopes of lead are found? 3. Lead 208, lead 206, lead 207. This confirms this method of explaining radioactive decay is correct. If there is any other decay process, I should get any some other isotope. No? So you are able to identify 3 types of lead isotopes naturally. Naturally, you are able to find 3 types of isotopes of lead means 3 types of radioactive disintegration are correct. Bismuth, naturally 209 isotope you are able to find. Are you able to understand? So these final products which are available in Earth crust confirms this theoretical way of explaining disintegration, radioactive disintegrations, natural radioactive disintegrations is acceptable. Understood, sir? Any questions in it? Now, one more thing. In all these disintegrations, somewhere in between, you will get a radon gas, a radon atomic number, a helium, neon, argon, krypton, xenon, radon, right? Noble gas or not? So we call that as gaseous emanation. What do we call it as? Gaseous emanation. What do you mean by gaseous emanation? Means during radioactive decay, if a radon gas is emitted, we call it as gaseous emanation. Right? Sometimes they will frame questions based upon this, and they will map or they will frame any questions related to gaseous state. Because all are emitting helium gases. So they can calculate, they will ask you if these many liters of helium gas is emitted, what will be the weight of thorium taken? They can frame questions in that way or not. Is it clear? So try to understand this. Any questions, sir? Respond. No, I am taking one note. This is about natural decay process. We are talking about artificial decay, sir, now. Artificial decay means naturally it is stable. We will make it unstable and we will make it emit radiation. Right? Actually, it is stable. We will disturb it, make it unstable. After making it unstable, then it start emitting radiation. Then it is called artificial decay. For example, aluminium 1327 nucleus. Aluminium metal. Aluminium 1327 nucleus. When bombarded with alpha particle, it is nucleus of aluminium. We are doing alpha ray scattering experiment now. There we have taken gold foil. Same way I am taking aluminum foil. So bombarded with alpha particles. Then can I write that reaction this way? Aluminium 1327 plus helium 24. Can I write like this? Right? Now it will give silicon. What is silicon atomic number, sir? Silicon atomic number. Phosphorus. What about phosphorus? So you will get silicon 1430 isotope and phosphorus 1530 isotope plus some other particles you may get. Let me assume this particle obtained is X, this particle obtained is Y. Right? So when aluminum 1327 nucleus is bombarded with alpha particle, we got a silicon 1430 nucleus and phosphorus 1530 nucleus. Both are obtained. Right? This happened approximately 95%. This approximately 5% happened. In general, what is the stable nucleus of phosphorus? 1531. So what you got 1530 means unstable. It doesn't exist naturally. Means it is created artificially. How I created this artificially? By bombarding aluminum 1327 with alpha particle. Now this phosphorus now undergoes disintegration to form silicon 1430 plus some other particle Z. Find X, Y, Z. Previous JEE advanced question. Find X, Y, Z. This is one artificial decay. In that decay, when aluminum 1327 nucleus is bombarded with alpha particle, you got phosphorus 1530 nucleus along with silicon 1430. And three particles are emitted. One is X, one is Y, one is Z. What are X, Y, Z? What is JEE advanced? Now tell me what is X. Tell me what is X. Electrochemistry. Not even opening the holes. We are doing maths. That's all, sir. I think today is my last class, sir. From next class, you will get another faculty. Leave it. I also got vexed up with you. Now, what is X value? 13 plus 2, 15. So here also I should get. So what is left? 1. So mass number is 1. Sorry, atomic number is 1. Mass number 27 plus 4. 31 in which 30 is here. 1. What is that? Atomic number 1, mass number 1. Proton. So X is proton. Now tell me what is Y? What is Y, sir? What is Y? 15. 15 over. So atomic number 0. 27 plus 4. 31. 30 means 1. So 0, 1. What is it? Neutron. Right? Now in this case, 1530 converted to 1430. So what is left? Mass number 1. Sorry, atomic number 1. Mass number 0. What we call it as positron. Sorry, electron means -1. I have to write. So this is positron. So during artificial decay, we got 3 types of particles: proton, neutron, and positron. And all aluminum converted to silicon 1430 finally. Correct or not? So stable nucleus was converted to unstable nucleus that was showing radioactive disintegration by emitting some other particles. We call this as artificial decay. Clear? Now, all radioactive decays follows first order kinetics, right? As they follow first order kinetics, All radioactive decays follows first order kinetics. What is first order kinetics equation? Rate constant K equal to 1 upon T log initial concentration upon final concentration. Instead of rate constant K, we are writing lambda. Instead of initial number of molecules, we write initial number of nuclei, final number of nuclei. Right? Or I will write Nt equal to N naught into e power minus lambda t. Now see this example. I am taking any one decay. For example, I am taking this decay. I am taking this decay. I am not bothered about alpha particles and so on. Right? Uranium 92 238 converted to lead 82 206. Right? So I have considered one rock or one asteroid in which I found uranium nucleus, lead nucleus, both. I need to find what is the age of that rock. How to find that age of rock or age of fossil fuels, age of artifact. How to find it? Right? How to find it? If I calculate mass of, if I find mass of uranium 238 upon 238, what you will get? If I calculate mass of uranium 238 divided with 238, what you will get? Number of moles, right? If you get 1 mole of lead means 1 mole of uranium gone, correct? So for that I am adding mass of lead 206 upon 206. What you got? What this indicates? Number of moles of lead plus number of moles of uranium. If I add both, you will get initial number of moles of means N naught. Correct or not? Divided by mass of uranium 238 upon 238. Now what you got? Initial number of nuclei upon final number of nuclei. I am taking logarithm. Response, sir, into 1 upon. I am bringing the t to this side. I will write lambda here. So instead of lambda, what I can write? 0.693 by t half. So I am writing it as ln2, and here I am writing t half of uranium 238. So by using this formula, what you can calculate now? You can calculate age of rock. Yes, sir. Yes, ma'am. Initially, uranium is there. That already started disintegrated. Yes. So you are saying when Earth was born, I was also born. So I am going to calculate it. Mind you are going to write JEE. Want to become engineer? Huh? What, sir? There in that small logic you are not able to find. What is the use of studying? Now listen, sir. There is one plate of laddus here. You started at home. At that time, I started eating laddus. Right? What I will do is, I will eat every laddu only to half of, and I will keep remaining half here. Right? When you started at home, I started eating laddus. I will eat only half laddu, and I will keep remaining half there. When you came here, there are 20 half laddus, so 30 full laddus. Now tell me, how many initially laddus present in it? Yes? You are saying, sir, initially there are no half laddus. You only told, na, sir, initially there are no half laddus. Na? Initially I have to take only full laddus. How you calculate it? Then, what? So when Earth was born, I don't know how much uranium present, but I know one thing. Every uranium nucleus converts into lead nucleus. Now I got one rock sample. In that rock sample, I will calculate how much uranium is present, how much lead is present. Right? Number of moles of lead plus number of moles of uranium equal to initial number of moles of uranium. That's what I have done. Weight of uranium by 238 plus weight of lead by 206. I got. If I add number of moles, that is nothing but initial number of moles of uranium or not divided by final number of moles of uranium. I can see now. I can calculate it now. So initial by final. Right or wrong? What, sir? Huh? If you ask that doubt now, it's not insult for you, it is insult for me also. Day by day, I'm losing interest in your facts. Right. So log term is over. Now come to that before log term. What I have to write? Lambda equal to 1 upon t. I brought t to that side. Then what should we get? 1 upon lambda. First order kinetics, no? For first order kinetics, what is the rate constant k? ln 2 upon t half. That's what I am writing. Instead of lambda, I am writing log 2 upon t half. T half gone to numerator. T half of what? T half of the initial material. What is that initial material? Uranium. So T half of uranium 238 divided by log 2 is equal to this term. Over. So this is how we are going to measure age of log 2. Right, sir? Better. All these things are not in chemistry. All these things you need to study in physics. That is the best way I can escape. Why to take all this headache? How many of you solved this year's paper one? This year's JEE paper, how many of you solved? No one will solve. So I will directly go to physics. Circular disk. This is magnetic field. Linear calculus. This is, what is this, sir? Again, magnetism. Significant figures, waste question. Lensor. This is wave optics. This is waves. This is electromagnetic radiation. This question you can solve. By using chemistry knowledge, you can solve, man. 35 into 10 power 7 photons of a frequency 10 power 15 Hz. If the energy of all these photons is viewed as an average energy being contained in electromagnetic radiation. Means number of photons is given, their frequency is given. How you will calculate energy? NH nu. So we calculated energy, right? Then amplitude A, taking permittivity of free space as mu naught, Planck's constant as this much, pi value. Then find that alpha. They want to find amplitude. By using energy, you need to find amplitude. How? Energy versus amplitude relation. Right. Better. This one. Two more plates. Vacuum constant wave waste question again. This is okay. Rotation. This is experiment. Yeah. Again, this one. Second question. With chemistry knowledge, you can solve this also. Second question in physics with chemistry. Consider electron in the orbit n equal to 3, hydrogen-like atom with atomic number Z, absolute temperature T, thermal energy kB into T, de Broglie wavelength of this electron. This temperature T is given as Z square H cross square upon A pi square A naught Mn into kB. Right? So what do we need to find? Then find the value of alpha. Where is it? Huh? Where is it, man? Oh, denominator, huh? Here. Find that value. Bohr's concept, Bohr's theory. By using Bohr's atomic model, we can solve it. Right? This is static electricity. Current electricity. Electromagnetic radiation again. Electromagnetic radiation again. So, structure of atom, electromagnetic radiation, both combined till now 3 questions. This is purely chemistry. I will go to paper 2. This is completely max. Waste question. Huh? Another waste question. Reasonably good. What is this? Gravity, yeah? Gravitation. Static electricity. This is optics. Thermodynamics. If you learn at least chemistry properly. Hydrogen-like atom initially at rest in its ground state absorbs a photon of frequency nu1 and ejects a Einstein's photoelectric effect. What, man? So, fifth question. Thermodynamics. Sixth question. Right, 6 questions. So, if you read chemistry properly, in physics also you can solve 6 questions. This year's JEE advanced paper I am saying. Right? Not only this year, every year, man. 2024 paper 1 I am opening. Prepare properly. Prepare properly. Everyone keep on saying this year physics paper is damn tough. It is not tough. It is easy. You are not studying. And simply saying that paper is tough. One parent came, he is saying, my son studied for 2 years. He is not able to score 1 mark. Then I said, he has not studied for 2 years, sir. He wasted 2 years. That's why he is not able to get 1. I paid fees. I am not saying you have paid fees. You throwed fees on our face. That is the fact. You are rich, you throwed face on our face, throwed money on our face. Saying that if you throw money, everything will happen. Same thing I am saying here. You are not listening to classes from. Doing maths, whatever you want, you are doing. No, this is mathematics, right? Waste question again. This year also, do they give question on dimension analysis? Sorry? What happened, man? Sorry, you fill it there. The screw is there. Huh? Come. In that is. So that's it. Stop. Outside and pin there. Done? There. Huh? Okay. What? Dimension analysis now? Structure of atom only again. But they gave potential energy. Energy equation, now potential energy equation. If I differentiate, you will get. Hmm? What about this one? Thermodynamics. No, this is sound. With chemistry knowledge, you can solve. Thermodynamics question. Can't solve this. Again, waste question or not? How many questions you might have solved? And based upon that, we need to plot the graph. Easy question only. Again, alpha ray scattering experiment. Response are, but by using X-rays. K alpha, K beta, what is Moseley's law? Alpha lines, beta lines. Again, what is it? How many times they are giving? Almost every year in every paper they are giving one question for dimension analysis, units and dimensions. If you observe all these papers, you will find questions from electromagnetic radiation, atoms and nuclei. Correct? Or either Bohr's model questions, Planck's quantum theory questions, or Rutherford's scattering experiment questions. Say something means and thermodynamics related questions. So whatever may be the paper, whether it is paper 1 or paper 2, all put together, minimum you are finding 5 questions, right? That are related to with chemistry knowledge. Can you solve or not? 5 questions, irrespective of any paper, right? Again, thermodynamics question. This is 2023 paper. Again, structure of atom question. Response, sir. Again, thermodynamics question. Solve. In which physics? Solve. Just now we discussed it, man. Right, 238 converted to 234, man. How many alpha? 1. Mass number 92 converted to 91. If it is 1 alpha, 92 should become 90, na? It became 91, increased. Means 1 beta. So answer must be 1 alpha, 1 beta. That beta must be beta minus. Beta means electron, na? So 1 alpha, 1 beta minus. Where is it? Fourth option. So P4 means CDR ruled out. Now R2 no need to check. Check for Q and S. If any one is correct, over. So check for Q. 214 converted to 210. 1 alpha. 82 converted to 82. 2 beta. So 1 alpha, 2 beta. Which one? 1 alpha, 2 beta. Means 5. No, sorry. 5. So Q must be beta minus. Where is it? Third option. Here. 1 alpha, 2 beta minus. So answer must be 3. So Q must be 3. So P4, Q3. No need to check remaining. So answer is how many marks? 3 marks. Waste question. Right? Black body radiation. Planck's black body radiation. Can you solve it? Leave it. In chemistry, they will not ask me questions of nuclear chemistry. But if you are thorough with chemical kinetics, nuclear chemistry is nothing. Again, thermodynamics question. Yes, sir. Go, sir. Question number 12. Can you solve? In a radioactive decay process, activity means rate. Activity A is given as minus dN by dt. Why they are writing minus dN by dt? Or dx by dt we are writing. Number of nucleus gone by dt. So activity is written as minus dN by dt, where Nt is the number of radioactive nuclei at a time t. Two radioactive sources, S1, S2. Two nucleus are there. One is S1, one is S2. Both are disintegrating. Have activity at a time t equal to 0. At a later time, means at initial time t equal to 0, S1, S2 both have same activity. Initially, both are disintegrating with same rate. After certain time, activity of S1 and S2 are A1 and A2 respectively. When S1 and S2 have just completed third and seventh half-life respectively, what is the ratio of A1 by A2? Means by the time first one disintegrated, that time, second one disintegrated, that time. This time equal to 3 times of T half. This time equal to 7 times of T half. Then what is that A1 by A2 value? Solve. Again, thermodynamics question. Yeah, you solve that. That was work to you. Can you solve it or not? Easy one or not? If you understand the question, nothing. You remember that question? S1, S2. Initial both have same rate. After certain time, in that time, S1 disintegrated 3 times, 3 T halves. For S2, it is 7 T halves. Then what is rate of S1, A1 and rate of S2, A2, A1 by A2 value? What is A1 by A2? Right? Again, nuclear chemistry question. Binding energy equal to delta mc square and E equal to mc square. Now we write binding energy B equal to delta mc square. Delta m is mass defect. Based upon that, you can solve this one. Means almost every advanced paper they are giving at least one question based upon radioactivity, nuclear physics. Correct? Solve question number 2. Again, same idea what we discussed now. Thorium 9230 decays to polonium 84 214. Ratio of number of alpha to number of beta emitted. Best question. Huh? What do you write? 30 minus 14. How much? 16 means 4 alpha. Means atomic number should decrease by 8. Correct? 90 minus 8 means 82, but it became means 2 beta. So number of alpha to number of beta 4 by 2. Right? How many marks? Again 3 marks. Again thermodynamics question. So till now we have seen 4-5 years. Okay, 3 years, huh? 25, 24, 23, 22. Almost every year you are finding question from nuclear physics. Means nuclear chemistry. Again, nuclear physics. This chemistry. Okay, half paper I saw. Again, thermodynamics question. Can you solve? A heavy nucleus Q have half-life 20 minutes. Undergoes alpha decay with a probability of 60%, beta decay with a probability of 40%. What they made? Small max they added, nothing there, right? So alpha probability is 60%, beta probability is 40%. Initially, number of Q nuclei is 1000. Number of alpha decays of Q in the first 1 hour is half. Time is also given. T half is 20 minutes. 1 hour means 3 T halves. Response, sir. In 3 T halves, alpha decay probability is 60, beta decay probability is 40. Now we can calculate. Possible or not? What is this? Structure of atom. See this. This question. But of course, they gave this in chemistry this year, 2021, paper 2. They gave this question in chemistry. 2x plus y. We solved a plus b gives rise to products. Now they gave 2x plus y gives rise to products. Rate of reaction dp by dt equal to k into x. Means rate of reaction depending upon only x, means it is independent of y. What is the order? First order, right? 2 moles of x are mixed with 1 mole of y to make 1 liter of solution. At 50 seconds, 0.5 mole of y is left in the reaction mixture. Which among the following statements are correct? What I have done? Same method we have done. See, as they gave 2, what I have taken? 1 by 2 dx by dt is equal to k into a minus x. Why I have taken only a minus x? They told it depend upon only x. So that's why we wrote it. I derived it, integrated. Finally, I got k equation. Right? Without deriving also blindly, we can give it this or not. Just now, how many questions we have solved? So k equal to 1 by 2t ln a upon a minus x. Substitute. Calculate k value. Calculate half-life value. When time equal to 50 seconds, what is rate value? At 100 seconds, what is rate value? Just a substitution and calculating. Easy or not? Electrochemistry question. No, we are seeing. We will see in physics. Huh? Chemistry, anyhow, you will solve those questions. Kinetics questions, you will get. At the same time, in physics also, you can solve few questions. Almost every year, they are framing questions based upon structure of atom or nuclear chemistry. What is it? Photoelectric effect. Response, sir. How many questions I need to show proof? Sufficient? Every year they are giving, man. More than sufficient. How many questions I am showing as a proof? That's why I keep on saying thermodynamics, structure of atom, chemical kinetics, nuclear chemistry, in chemistry, particularly electrochemistry, solutions and colligative properties. If you are thorough with these chapters, for sure you can answer 10 questions, either in physics or chemistry. Clear? And you people are not even opening the paper. This year's paper also you have not seen. What is this, sir? This we discussed last year. First chapter we discussed it. Huh? Millikan's ion drop experiment. Derivation also we have done. If you remember, this also I derived in class. P equal to P naught into e power minus mgh by RT. Hot air balloon. Payload. Gaseous state chapter. There I derived this equation. Kinetic theory of gases chapter. Thermodynamics, man. Newton's law of cooling. Periodic classification. I will show one more question and I will end it. Only this 2020 paper one I will show and we will come back. We'll start discussing. This idea, these type of questions we solved. While we are discussing about pressure, we discussed it. A U-shaped tube, manometer, open end manometer, closed end manometers, barometers, discussed or not? Right? Pressure equal to rho hg cos theta. Something we discussed. Structure of atom. No, go sir, go sir. Thermodynamics. Isothermal, work done in isothermal upon adiabatic. Right, I am closing it. So what you understood based upon all this? What you understood, sir? Structure of atom, chemical kinetics, nuclear chemistry, thermodynamics. Right? These 4 chapters are very, very important both in physics and chemistry. Right? Clear up? Now I am framing one more question. You try to give rate constant. I am taking one example. Now say this. As long as we are alive, we keep on eating something, means carbon content. So whatever food we are taking, all it is carbon only, na? Right? What we are exhaling, carbon possessing compound only, right? So as long as we are alive, we will take carbon and we will emit carbon content, right? Means percentage of carbons and its isotopes in our body remains constant because we keep on taking it, we keep on emitting it. So what happens? It keep on restoring to original position. Na? So as long as we are alive, isotopes ratio, carbon have different isotopes, na? C12, C13, C14. These ratios remain constant. The moment you are dead, what happens? Carbon you are not going to take. But whatever carbon content present in your body, it starts disintegrating. Particularly C14 isotope, carbon 14 isotope will emit radioactive. So it starts disintegrating. Then what about amount of C14 in your body? Decreases. Right? After 10,000 or 20,000 years, or after certain time, they found your fossil. And they calculated what is the percentage of C14 in your body now. What is C14 present in my body now? Can you calculate what is the age of this bone or fossil? Because when I am alive, when he was alive, percentage of carbon in our bodies remain same. Because he is also when that animal was alive, or that dinosaur when it is alive, it is feeding on carbon only. We are also feeding on carbon content only, no? Correct? So at that time, percentage of C14 in its body and percentage of C14 now in my body, both will be same. So initial C14, I know. What I will do now? What is C14 content in that fossil? Now I will calculate. So C14 present in me divided by C14 present in that fossil gives initial upon final. Correct or not? So I am writing C14 to C12 ratio in living upon C14 to C12 ratio in dead or wood. Or dead or wood. Correct or not? Or as long as it is alive, we call it as tree, man. When it is dead only, we call it as wood. Correct? So living upon dead, or can I call it as fossil? Take logarithm. What you got? Here I am writing T half upon ln2. Right? So by using this formula, what you calculated? Age of fossil. Response, sir. So we call rate constant. Here disintegration constant. There we call it as rate. Here we call it as activity. If it is first order kinetics, what you will write? In case of first order kinetics, what you will write? Activity equal to lambda into nt power 1. Rate constant equal to, rate equal to rate constant into at power 1. Here I am writing a equal to lambda into nt power 1. Correct or not? Where a is called activity, is nothing but rate of a reaction. What is lambda? Activity constant, or we call it as disintegration constant. Response, sir? Will you understand? Right? So I am coming back to our study. Any questions do you have about this? All radioactive disintegrations follow first order kinetics, right? Some theory also, what I have done is in my class notes, I will upload that class notes. In that theory also I have given, I uploaded. Better I will show it once. Say this nuclear chemistry. Say this, sir. This is about chemical kinetics. From here, nuclear chemistry starts. What is it? What we have discussed here? During alpha emission, atomic number decreases by 2, mass number decreases by 4. Then what happens to the position of that element in periodic table? Do it change or not? Or if atomic number is decreased by 2, it changes towards the left side by 2 positions. If it is emitting beta, towards the right side by 1, and atomic number is increasing by 1 unit, na? So in periodic table, it will move towards right side. If it is emitting alpha, left side, right? We call that as Soddy-Fason group displacement law. We call that as Soddy-Fason group displacement law. For every alpha particle emitted, position of element changes by 2 units towards left in periodic table. Position of element changes by 1 unit in periodic table. Number of alpha particles emitted, number of beta particles emitted, we derive. Same thing we have seen now. Right? Response, sir? Now, radioactivity. What is radioactivity? Any unstable nucleus converts into stable nucleus by emitting particles is called radioactivity. Parent, daughter. If daughter is not stable, then it becomes again parent, daughter, it goes on. Right? It is classified into two types. Artificial, natural. And in natural, 4n, 4n plus 1, 4n plus 2, 4n plus 3. Done or not? Say something. Artificial also, just now we have solved this problem or not, old JEE question. Some examples we have written at one place. Electron, positron. Radius of nucleus, we studied in structure of atom itself. Radius of nucleus R equal to R naught into A power 1 by 3, where R naught is nothing but approximately 1.33 Fermi. Right? Density of nucleus is always constant. For all nucleus, density of nucleus remain same. Right? Now, some properties of alpha, beta, gamma. Right? Positively charged, negatively charged, no charge, that is radiation. These two are particles, some theoretical concepts. Right? Now, these things you will study in physics. Binding energy per nucleon, N by P ratio. That we will discuss after completion of this chapter, we will discuss at the end. Right? Binding energy per nucleon, N by P ratio. Right? Once that is done, we will study about rate. Just now we have discussed lambda equal to 1 by T log base E or 2.303 by T log N naught by NT. Correct? Now, their rate of reaction, no? Units, moles per liter per time. Here we call it as activity, no? Right? So activity units will be Curie or Rutherford or Becquerel. Curie means 3.7 into 10 power 10 disintegrations per second. Rutherford means 10 power 6 disintegrations per second, or Becquerel means 1 disintegration per second. Or there it is moles per liter per second. Here it is disintegrations per second. In terms of Curie or Rutherford or Becquerel. Half-life, you know. One more thing is there, average life. Average life means 1 upon lambda is called average life. 1 upon lambda can be written as 0.693. T half goes to numerator. So T half by 0.693. It can be written as 1.44 times of T half. This already we have seen. Types of nuclear disintegrations. Nuclear fission, nuclear fusion, Bremse-Stachelon, right? Spallation reactions, types of reactions, just theory only, just I will explain after this. After that, uses. A's of fossils, just now we have seen. A's of rocks, we have seen. Done or not? So few more concepts, if you discuss, that nuclear chemistry part will be very, very easy and small topic, right? So we are studying about first order kinetics now. So examples also we have done. Experimental methods of determining first order reactions. We are discussing about experimental methods. Go sir, go sir. In case of first order reactions, we are studying only in case of first order reactions. Again, I am saying if you show interest, we will help you. If you don't have interest, we will complete syllabus. Simple. Right? Every day you need to do some work, something you need to learn. Without wasting time, you need to concentrate. Now say this. Irrespective of any method, sir, irrespective of any method, we can measure rate constant in terms of volume, in terms of pressure, in terms of optical activity, and so on. Right? Just remember this format. K equal to 2.303 by T log V infinite minus V naught upon V infinite minus Vt. If you want to measure rate constant in terms of volume, in terms of pressure, in terms of optical activity, optical rotation, observe all are having same format or not, whether all have same format or not. I am taking one example. Ammonium nitrite solid. This on heating, what you will get? This year JEE advanced first question, sir. In chemistry, paper 1, first question is this only. Thermal decomposition of ammonium nitrate following first order kinetics. What you will get? Any ammonium compound having oxygen on heating. Over. So what you got? N2 plus 2H2O. I am taking liquid, right? Initially at time t equal to 0, let me consider A moles of this is present. After a certain time, it becomes A minus X, then it becomes X, and this becomes 2X. When time t equal to infinite, it will react completely. Then this becomes A, 2A. Correct, sir? Respond. Yes or no? We know that ammonium nitrate follows first order kinetics. We are studying about first order kinetics only. Now, I am measuring volume of N2 gas. I am measuring volume of N2 gas. Volume of N2 gas, maybe at STP or NTP, whatever it is. At a time t equal to 0, let me assume that as V naught. Here let it be Vt. Here let it be V infinite. Can I write volume of nitrogen gas at V infinite is directly proportional to number of moles of N2 gas? Yes or no? If number of moles of N2 gas is more, its volume is also more. Here is proportional to X. Here 0. Yes or no? Now substitute this data here. V infinite minus V naught. What is V infinite minus V naught upon V infinite minus Vt value? V infinite minus V naught upon V infinite minus Vt equal to. It becomes equal to A upon A minus X. Just if I substitute these volumes, you will get first order kinetics or not? Response, sir. Right? I am taking one more example. Hydrogen peroxide decomposes to form H2O plus half O2. Now, at time t equal to 0 again, let it be A, not there, not there. When time t equal to t, let it be A minus X, X, X. At time t equal to infinite, this is not there, this is A, this is A. Right? Now, I am calculating, I am estimating hydrogen peroxide. Now, I will estimate hydrogen peroxide in a different way. Volume of KMnO4 required to titrate hydrogen peroxide. I want to titrate hydrogen peroxide by using volume of KMnO4. Now, initial volume required is V naught. Now tell me, what is the volume of KMnO4 required now? Is proportional to the amount of H2O2. If more amount of H2O2 is there, I require more volume of KMnO4, na? So V naught is proportional to A. Vt is proportional to A minus X. Correct, sir? V infinite is 0. Now again, V infinite minus V naught upon V infinite minus Vt is what it is. V infinite minus V naught minus A. V infinite minus Vt minus of A minus X. What is it? A upon A minus X. Again, can I substitute here? Respond, sir. Right? In any format, can you do it or not? Now, instead of this, I am taking one more example. SO2Cl2 gives rise to form SO2 plus Cl2. I want to make it a little complicated. What I am doing is, initially, let it be A, this is B, this is C. When time t equal to t, let it be A minus X, then this becomes B plus X, C plus X. At time t equal to infinite, not there, B plus A, C plus A. Right? Now, I am measuring pressure of gases present inside the container. Total pressure of gases present inside the container. Initially is P naught. Now tell me, P naught is proportional. All the three or not? So P naught is proportional to A plus B plus C. PT is proportional to A minus X plus B plus X plus C plus X. So what do you get? A plus B plus C plus X. P infinite is proportional to. Right? A plus B plus C plus A. Can I write it? Can I write it or not? Now tell me, what is P infinite minus P naught upon P infinite minus PT? What do you want? Again, you got same format or not? It is in the format of A upon A minus X again. Are you able to understand, sir? Right? Sometimes they will give you these values and they will ask you to calculate A upon A minus X value. Accordingly, you do the calculation. Clear? Any questions in it? I will solve one question related to that. Then I will go back. Go. Can you solve question number 24? Question number 24. I don't know. You solve and tell me. What I am writing? A gives rise to B plus C. Correct? Huh? Now initial pressure is P naught. So at time t equal to 0, I am assuming A, this is not there, this is not there. I am assuming A minus X, X, X. Right? So what is P naught? P naught is proportional to. And PT is proportional to. Hey. PT is proportional to this plus this all are gases, no? So PT is proportional to A plus X. Now, how I will get A minus X star? How I can get A minus X star? What is P naught minus PT? So I am writing P naught upon P naught minus PT. Yes, sir. What I will get? 2P naught. Huh? Okay, 2P naught minus PT. Now, what you will get? A minus X. Huh? So this is nothing but equal to A upon A minus X. Over. Correct? Huh? Response, sir. I will take one more question. Question number 31. Similar idea. Solve, sir. It is same as A gives rise to 2B plus C. A gives rise to 2B plus C. Check. Correct? Huh? Response, sir. Right. Right and solve. Total pressure is given as P. Initial pressure is given as initial pressure is P naught. Final pressure given as P. We need to find first order kinetics. One small thing, sir. Same above question, I am solving in different way. Same above question, I am trying to solve in a different way. Observe this. What is initial pressure given here? P naught. I am writing here pressure as P naught minus X, X, X. Correct, sir? Now, P naught plus X equal to PT. Reason? What they give? Final pressure is given as PT or not? So P naught minus X plus X is nothing but equal to PT. Now, what is rate constant K equal to? 2.303 by T log initial concentration by final concentration. Means what I have to write? P naught upon P naught minus X. Correct? Response, sir. P naught, A naught upon AT. This is A naught, this is AT. So P naught upon P naught minus X. Now from here, X can be written as PT minus P naught. Therefore, P naught minus X equal to P naught minus, instead of X, PT minus P naught. Response, sir. I want to find this value, man. So what is P naught minus X? P naught minus, instead of X, I am substituting it. So what you got this? 2 P naught minus PT. So substitute. So equal to 2.303 by T log P naught upon, instead of P naught minus X, 2 P naught minus PT. Same thing, na? Response, sir. Correct? Initial concentration by final concentration. Right? Correct? Now come to this one. How to solve this one? I am writing this as A gives rise to 2B S plus C. At time t equal to 0, what they give? P naught. At time t equal to t, they gave this value as P naught minus X, 2x, X. From here, what is PT equal to? P naught plus 2x. And total pressure now is nothing but this plus this plus this is not total pressure. So PT is nothing but P naught plus 2x. They gave that PT or P. In question, they gave that as P. Correct? So if it is following first order kinetics, what is the formula? K equal to 1 by T logarithm initial concentration upon final concentration. This I need to substitute. So what I need to substitute here? So first I will find P naught minus X value. So from here, what is X equal to? P minus P naught by 2. Therefore, P naught minus X equal to P naught minus P minus P naught by 2. Correct? LCM. P naught minus P by 2. Substitute. Hmm. 2 P naught upon P naught minus P. Huh? Yes, sir. This subtraction is there, man. Correct? Then what you got? 2 P naught. This becomes 2 P naught minus P plus P naught upon 2. So totally 3 P naught minus P upon 2. Substitute that now. So what you got? 2 P naught upon 3 P naught minus P. Correct, sir? So what is the equation? But they gave minus. May take reciprocal. So minus KT equal to log 3 P naught minus P upon 2 P naught. Response, sir? So what should be the answer? Second option, huh? Same idea or not? Can you solve this one? Just now we solved. Right. We wrote A gives rise to 2B plus C. But this is given as solid. This is given as solid. So solve that question number 41. Solve that question number 41. Online, no one is responding. Hmm? I think better to stop sharing for online students. No use, you know? They are not even the funds. They are not even alive. Can you solve now? So shall I go to next topic? To solve it. Now observe this case. Observe this case. I am taking sucrose. On hydrolysis in acidic medium gives glucose plus fructose. What is the optical activity of sucrose? Plus 66.5 degrees. Already we discussed in man pseudo first order reactions. Check once. Have we discussed or not? Plus 66.5 glucose. Pseudo unimolecular reactions. Right? Right? You have not given that value. You also not given. Right? What is glucose value? Glucose. Array formula, not formula, man. Optical activity. Optical rotation. Optical rotation. This is our people. Optical rotation. Where we discuss this? Class 11th. In GOC. While we are discussing about optical activity, we discussed it. Yes, sir. Go. Plus 66.5. Glucose is plus 52.5. Fructose is minus 92. This is a plus 52.5. This is minus 92. Right? When I'm seeing optical rotation, in spectrometer, when I'm seeing the reading, what we will do? We'll pass plain polarized light to the cuvette and we will measure the length of the cuvette in decimeters, concentration in terms of gram per ml, then specific rotation alpha equal to observed rotation upon L into C, length in decimeters, C in gram per liter. Correct, sir? Specific rotation equal to observed rotation upon L into C. Right? Initially, I'm using only sucrose. Then it shows a value of plus 66.5. Means plane polarized light will be rotated towards clockwise for an angle of 66.5. So can I say you will get a value somewhere here? Optical rotation value at time t equal to 0. If it got reacted completely, if this got reacted completely, what will be the final value? If if it got reacted completely, what will be the final value? What did you get? This gives plus 52, this gives minus 92. So what is the net value? Optical activity per mole? Minus 20. This plus 52, minus 92, close to minus 40 per 2 moles. Per mole. Minus 20. So minus 20 means instead of clockwise, I should see the value in. So I can write somewhere here, I will get that value. This is R value at infinite time. Means when reaction got completed. Right? At certain time, you will find that RT value somewhere in between these two. Yes or no? Let me assume at some time I got this value RT. Now, what this indicates? What is this R infinite minus R naught? This indicates R infinite minus R naught is proportional to A. R infinite minus RT is proportional to A minus X. Correct, sir? This is proportional to A minus X. That's why we wrote K equal to 2.303 upon R infinite minus R naught upon R infinite minus RT. A upon A minus X. When optical rotation is given. Is it clear? That is mean, sir. Solve this question number 24, sir. JEE Advanced 2024 paper 2. Last year paper, ma'am. Last year paper 2 question. Solve. 2024 JEE Advanced paper. When the age of sample is a 10 into, sorry, P into 10 power 8 years, ratio of mass of lead 206 to that of uranium 238 in the sample is found to be 7. The value of P is very, very, very easy question. Done. Shall I solve? What's that? Listen. What is age of rock formula? T equal to T half upon 0.693, right, into 2.303 log mass of uranium 238 divided by 238 plus mass of lead 206 upon 206 divided by mass of uranium 238 upon 238. Separate it. This upon this plus this upon this. What you will get? 1 plus 1 plus this by this. What you can write as? Mass of lead 206 divided by mass of uranium 238 into 238 upon 206. Correct, sir? Log of this value 2.303 into what is T half? Oh, no need of this. No, okay, let it be. Let it be. So 2.303 into T half 4.5 into 10 power 9 upon 0.693 is equal to what is the T? P into 10 power 8 years. And I wrote T half also in years. T half also in years. So this is in years, here also in years, right? What is this ratio given? 7. Calculate that part. So P equal to, can I cancel this at 10 power 8 and this? So you'll get 10. Response, sir. This 0.3010 times, correct? So approximately 0.3 times. Correct? Then I can write it as 45 by 3. Response, sir. Log this one 206. No, instead of that, let me write this as 1 plus 7 into 238 by 206. 7 8s are 56. In last number is 6. In 6 table, you can get 6 or not? 6 times. Response, sir. Right? So if I divide this, how much would you get? 8 6 are 48. So 7 7 8s are 56. 56 means it should be greater than close to 9. 9 7s are 63. No. 9 6 are 54. I should get 6 man. So 6 are 42, 8s are 48, 9s are 4, 11. I think I can get 11 there. 7 into 238 by 206, not even 11. 1.7 thing around maybe 8. Not even 8, I think so. 7.7, 7.7, 7 into 238 divided by 206 plus 1. Oh, sorry. This value plus 1. Log 9, 3 square. 2 log 3. 3 is 0.4771. 2 into 0.4771. 2 into 0.4771, man. You got this value as 9, man. Log 9 I am writing 2 log 3, right? Log 3 is 0.4771, approximately 0.5. Okay, approximately 0.5. 45 twos are 90 by 3 into 0.5. So answer must be close to 15. They are asking nearest integer or not? Are they asking nearest integer or not? Huh? So that also you will calculate exactly. Log, oh, I cannot find log of. Okay. Log of 9 into log 9 into 45 divided by 3 into 2 into 2 what do you got? 4 450 by 3. 4.5. Oh, another 10 is there. Okay. Okay, another 10 is there. Right. Another 10 is there means I will write as 450. 450 divided by 3 into 2 into 0.4771. I am writing approximately 0.5. 3 15s are 150. 150, 2 into half, 1. So 150 into 1, 150. So answer must be close to 150. Correct? Response are right. Can you solve question number 21? 2020 paper 1. Observe, sir. These type of questions they are giving in chemistry as well as physics. Solve this one. AZ mass number is M. Decays to BZ minus 6. Mass is M minus 12. That is stable. Half life is 10 days. Right? And you are getting alpha particles. If m grams of A are taken and kept in a sealed tube, how much helium will accumulate in 20 days at ST in liter? Up. Again, man. A Z mass number M converted to B Z minus 6 mass number M minus 12. Right? Given T half equal to 10 days. How many grams of A you have taken? Means 1 mole. The mass number is M na? Means initially you have taken 1 mole. After 20 days, T half is 10 days, na? 20 days means 2 T halves. In 1 T half, it becomes half. In another T half, another half. Right? 1 by 4. So it becomes 1/4. Means how much gone? 3/4 gone. Correct? Response, sir. So 3/4 gone. Now, how many alpha particles got emitted? Plus 3 alpha. Correct? Response, sir. Means how many moles you will get? 3/4 moles of this you will get. Plus 3 into 3/4 moles of this you will get. Response, sir. 1 mole gives 1 mole. And you will get 3 moles. How much gone? 1 became 1/4 means 3/4 gone. If a 3/4 gone, you will get 3/4 of this or not? And how much amount of this? 9/4. Right? So 9/4 moles of helium is obtained. What they are asking? So what you will write? 9/4 into 20.4 liters. This is 5.6. 9 6 are 54, 5, 45, 5. So answer must be 50.4 liters. Sponsor. Check the answer. Correct? Better I will stop today's discussion. So we are discussed regarding first order, and we have seen experimental methods of determining first order, right? And we have seen kinetics of radioactive decay, natural decay, artificial decay. That's all, right? So we'll continue remaining topics in next class. So I will stop today's discussion. Online students, you can leave, sir. No one
Thank
is
you, sir.
answering. No
Thank
one
you,
is
sir.
listening. Really, are you solving problems or not? That is also a question. Right, sir. Bye.